her. So, okay, so today we have, we have the pleasure to have Loreto Bravo, who is director at the Data Science Institute in Chile. And she's gonna talk about a mobility index they developed based on telecommunication data to help decision-making during the COVID-19 pandemic. And I will leave it here and give it over to you, Loreto.
Thanks. Thank you very much for the invitation.
Thanks for joining us.
One of the things that has happened with this pandemic is that I haven't traveled for 2 years, so my English might be rusty. So if I bear with me, I'll make mistakes, I'll forget, I'll speak half in Spanish. And also this talk or these topics, I've been treating them always in Spanish. So let's see how it goes.
No worries. I mean, I've been living here and still make mistakes. I think you're very...
Okay, so I'll share my screen. So first, it's important to acknowledge that this work has been done in collaboration with Movistar, which is the brand of Telefónica for cell phones in Chile, and funded also by Cisco. Okay, so this is like the agenda for today, where I'm going to introduce a bit about our Data Science Institute. Then I'm going to present the Telefónica Movistar data, like what type of data we have access to. A small intro about what happened in Chile with COVID so that you get an understanding of what we see in the data later. Then I'll present the COVID mobility index that we used to measure mobility and the results that we found using this mobility impact index. Then I'm going to present some impact that this mobility index had in Chile. And to close, I'll present other projects that we're working in so that we can explore possible collaborations. Okay, so let's start with the Data Science Institute. So where are we? South America, we go to Chile. Chile's capital is Santiago. And right here up over the mountains is Universidad del Desarrollo. That's my university where I lead the Data Science Institute. The Data Science Institute was created in 2016 through an alliance with Telefónica, Telefónica Chile. What happened was Telefónica was doing some R&D work, but they noticed that most of the pressure was to do things related to the business and not really see like possible new products or understand the data they had. So they decided to create this alliance with our university so that we would work with their data in a long-term agreement. So we've been working together already for 5 years. So the institute, like the core members, is quite small. It's just 8 of us, and but we collaborate with different professors of other faculties. As an institute, we are interested in being close to the private sector. So originally, we've been working with Telefónica, but we've been looking into collaborations with several other companies to have access to new data. So for example, we're working with Telefónica, Cisco, Copec, which is a gas company, Transbank, which is the company that handles all the bank transactions, the credit card transactions, Fundación Paz Ciudadana, which is an NGO that works with crime. So we're looking into crime and mobility issues. Telco, that sells cars, Santiago Smart City, and the Central Bank of Chile. And with most of them, we have long-term agreements where we basically say we want to work together. They put money in the Data Science Institute and we work with their data and create different projects and work in a long-term basis. It's not project-based, but agreement-based, long-term sort of agreement. So our longest agreement is with Telefónica. And first I want to give you some figures about cellular use, mobile phone use in Chile. In 2018, we had approximately 106 devices every 100 people. 2020 was already 136 devices per every. So basically, It's more than one phone per person. Before, the blue line is contract, and the red line is post-payment. Before, most of the phones were post-payment. Now in 2019, it changed, and now we have more contracts, which is relevant for the type of data that we have, because when you have a contract, you actually have the information of who is using the phone, not in the case where it's prepaid, okay? Movistar, which is the company, the brand, the mobile phone brand of Telefónica, has 24.4% of the market share in Chile. So basically, that's the amount of data that we have. We have, from March 2020, was 6 million unique devices that we were working with. But we needed also to check how representative this data was. So Movistar made Telefónica made some studies of representativeness inside the company, and they showed that it's actually quite well distributed geographically, and also in terms of income. We made an analysis where we actually made a correlation between the population estimated from the CDRs, from the data of the telecommunication, and the population of the census, and we get a pretty good correlation. So we are at the level of comuna, which is the basic, like, municipalities. I don't know how they are called in the UK. So we're pretty happy with how representative is the data, okay? So we have several types of data sets. Yeah, we have CDRs, which are calls, information of calls, XDRs, which are extended detail records that have information of data downloads, control plane records, which is more passive, so it's well, I'll go into more details in a while, and the package inspection, which is all the information that it's passed in the network. I've mainly worked with these two, but if we need, we can have access to this other, and we have some projects in which we have worked with these other sources. So I'm going to explain the first two, focus on the first two. Call detail records basically have the number of origin, the number of destination, the tower of origin, the tower of destination, the date and time the call was made, and the duration of the call. There's tons of other attributes, but those are the main ones, okay? And in this call detail record, either this or this number belongs to Telefónica. Okay, so if one of the two belongs to Telefónica, it's going to be in the CDRs. And the other is the extended detail records, which create a record every time data is downloaded. Okay, not every time, like there's like a 15-minute wait. So you wait 15 minutes and then that information is recorded, how many kilobytes were downloaded. So here you have the phone number, the tower to which you connected, the time at which you connect, and then the amount of kilobytes you downloaded. These are much low level, like you have much lower level. You have information of the protocols of, and I don't know, the information that the phone number tried to connect to this tower. You have, this is much, has more detail. It's important to clarify that this type of data is not GPS data. We do not have GPS information. Here is the connection to the towers. Okay, it's not Wi-Fi, Bluetooth. We don't have a triangulation either. Like we just have the information of where the phone number, this would be phone A was connected to tower A when it made the call to phone B, which was connected to tower B. Okay. If we analyze the numbers of events that we have per hour, and the number of records, sorry, that we have for CDRs, this would be the calls, this would be data, and this is passive. What you see is that CDRs is, of course, very sensitive to the hours of the day. During the night, there are almost no records because, of course, people are sleeping. There are no phone calls or much less phone calls. XDRs, since it's a combination of human triggered and also, I don't know, downloading emails, downloading updates. It's a mixture between machine and human interaction with the network. And CPRs are more, there's still this mixture, but they are very, very detailed, okay? So this is some characteristics of the data. We've done several projects with this type of data. Some examples are when when Pokemon Go was launched, we tested to see if there was any difference in behavior, and we found that during the daytime there were 13% more connections in the spots where you had the Pokemon stops, and it changed the way people had lunch, and after dinner they would go out. So we saw
Yeah, sorry, I was just wondering if it was me.
No, yeah, it seems to have lost
okay.
connection.
Yeah, brown bag is broken.
algorithms, and also we have.
Hi, Loreto, sorry, I think we lost you for some connection problems.
Now,
so,
can you hear me?
Yeah, now we
okay.
You were
last
talking
30
about
seconds or so.
Yeah,
okay.
Exactly. No more.
Sorry about that.
No problem.
Okay, so mall mobility, what we did was analyze the impact that social diversity had on the selection of a mall. So people were willing to travel longer distances for more, there was a correlation between more diversity and the willingness to travel longer distances. One of the nice things of malls is that they have indoor towers. So it's easy to detect. Why we did it for malls is because it's easy to detect that someone is within the mall. Since we don't have GPS and we have tower information, we were able to detect when someone was within a mall. So here we have two publications, one related to home detection algorithms and the other shopping mall attraction and social mixing. And finally, one other project that we have is mobility and gender, where we analyze, we ask Telefónica to tag the phones with the gender of the owner of the line. So basically, we were able to analyze what are the difference in mobility between men and women. Okay, so it was one of the most interesting results was that even if you gave access to more access to public transportation, women wouldn't move more. Okay, so you always found that men move more than women, and even if you provided more transportation, it didn't modify their behavior. So basically, that's a general idea of the Telefónica data that we have. So Chile and COVID. What happened in Chile with COVID? Well, here we have the opposite in the sense that right now we're starting summer. So this spec here in July is our winter 2020. And this over here is our winter 2021. The two peaks are correlated with winter. Okay, so this is the number of cases, but as you can see, the number of deaths is smaller in the second wave, probably, well, there might be many reasons, but one of them is that we have very good vaccination statistics. So we started vaccination in February, and as you can see, as of 8th of November, you had that 81% of the population is fully vaccinated. So To do the analysis, we have to understand that Chile is divided in several regions, and each region has several communes, comunas, and in total, Chile has 346 communes. And one of the things that was tried in Chile, I would say unsuccessfully, was to have partial quarantines, partial lockdowns. It's not that they said, okay, this whole region or the whole country goes to lockdown, but it was like, I don't know, sometimes they would choose these three communes and say, okay, these 3 communes go into lockdown and all the rest is open. Or even weird things like saying, this area goes to lockdown on weekends, and this other over here, the whole week. So they had very localized decisions made by the government. The decisions were made by the central government. So local governments were left with less options on how to reduce mobility to control the propagation of COVID. So what sort of things they could do and they tried to do was sanitary fences, closing governmental offices so that people would work from home. Also provide like mobile stores, like put mobile shopping centers so that people wouldn't need to travel long distance to get their food or bank and stuff like that. So to get an idea of the timeline of the beginning, so that when we see the data, we see how this impacted the mobility. We have that in Chile, the first case arrived on March 3rd. It was a trip from someone that came from Europe, and it arrived in a school here in Chile, and it started propagating really quickly in the richest areas of Santiago. In March 16, all the schools were closed, and the frontiers were also closed. On March 20, these 3 communes started quarantine. These 3 communes are on the rich side of the city. On March 22nd, we started with a national curfew that meant nobody could go out, like there were like militaries outside between midnight and 5 a.m. Nobody was allowed to leave their houses during the night. This was removed just a month ago. So since March 22nd until October 2021, we had a national curfew during the whole night to avoid, I don't know, parties where this like have more propagation of the virus. On May 15, the entire Santiago metropolitan area went into quarantine. This is Santiago metropolitan area, now some other communes of the area. And finally, in March 27, they started to move outside of Santiago, outside of the capital. And after this, during the rest of the pandemic, we were shifting, like it would move from Santiago to the rest of the country, then it would travel back to Santiago, and it would go away from not go away completely, of course, but you get this fluctuations because the country is really long. So it's not that we were all in a critical situation at the same time. So the COVID mobility index. So to get a general timeline of the work we did during the pandemic is on March 19, the project started. Let's say on March 19, we said, you know what, we have access to this amazing data. Maybe we can help and provide information so that the government makes informed decisions about what's going on. We wrote a first report with the international collaborations, a lot of people from Italy, from the US, where we made a general analysis of the data. On April 16, we were invited to the Senate to present what we were doing and to understand what were the needs of the government and to determine better how we could help. On April 22, I was invited to start working with the government in a COVID data task force. That the idea was to collect the data that could be used by scientists and the society to better understand and find solutions for this crisis. I'm still working with the government in this task force, but the objectives have changed a bit, but it's been very intense work with them. On April 23rd, we signed the agreement with Cisco, that Cisco provided funding so that we could develop their reports, because we basically started writing reports, weekly reports. So each week we would create one report for each of the regions of the country and one report for the whole country. The first report was published on April 30th, 2020. And this report was distributed to the government and also published so that it could be used by local governments. We also had meetings with the local governments and helped them analyze their local strategies. Yeah, so it was a pretty intense year in terms of the work that we did with the community. Press was amazing, like there was a lot of interest in the results that we had. And also we did something that working with the COVID data task force in May 27, we actually started publishing this data so that it would be available in the Ministry of Science GitHub page, and it's still available, it's still there. So what was the data we had? We had anonymized XDRs. So remember, the XDRs is the data that every time that data is downloaded, a line is created. So when we have this data starting March 2020 until now, okay, we have the phone ID, which, as you can see, is anonymized, using a hash function. So basically for two phone numbers, if we have two entries for the same phone number, it will be the same code. We have the ID of the tower and the antenna associated to this data download, and we have the event time. At some point, we also asked them to provide us with the kilobytes. Okay, so we also had the kilobytes that were downloaded in that when it was used. We analyzed the number of connections that we saw during the day, and sometimes we had some outliers. When we had outliers, we just ignored the data. There are some weird things happening sometimes with the data that not even Telefónica is able to explain. So when we had very regular behavior, we actually decided to not report those days. So basically here we had two challenges. The first one was the distinction between trips, let's say, and amount of movement. Because you might have a trip that goes all the way from Santiago de Chile to the extreme south in Punta Arenas, and that's one trip. But the amount of movement, let's say, involved in that trip is much more than if it's me doing a trip from my house to the supermarket that's 2 blocks from my place. Okay, so we didn't want to use the definition of trips. Okay, we wanted to be measuring movement in a way. Second of all, we needed a very simple algorithm, because we were actually, sometimes the government would ask us, you know, like, what happened last weekend on Monday? Like, they will be like, what happened last weekend? So we actually needed to be able to compute really fast the index, and it had to provide information. So first of all, Telefónica had the best of attitudes, let's say. They were very committed to helping in the pandemic. So they actually made the whole process really fluent. So they actually automatized everything so that we would get the data of Sunday on Monday night. So it was actually really fast how they would just take this large amount of data, anonymize it, and put it at our disposal. So we made the following decision. Instead of considering trips, what we were going to do was measure transitions. Okay, so basically, I am home, I'm connected to an antenna. I then go to the supermarket, I'm connected to a different antenna. And then I go to a very long trip and I pass through several antennas in the trip. So basically the transitions are the number of changes between one antenna and another. There are several things that allow us to do this. One of them is the fact that generally these transitions don't happen very frequently. They generally, the system is checking about 15 minutes if you change tower. So it's not that it's all time changing towers, okay? So our mobility index is basically the number of transitions that that you can count in a certain area divided by the number of devices that you can consider that are residents of that area. So at the beginning, we wanted to see how sensitive this was. So basically here we have the mobility index for one of the communes, Las Condes. Las Condes is where our university is located. And we have here if you see the numbers are quite large because this is the average number of transactions considering both local residents and the floating population. So basically, what you see are things like expected in the sense that during the week, you have larger mobilities than what you would observe during weekends. Grays are weekends, and these sort of pink areas are lockdown. Okay. Let's remember that the lockdowns are very localized. So it might be that Las Condes is in lockdown, but all the neighboring communes are not. And what we observed, one of the results that we found, of course, is that when neighborhoods, the neighboring communes are not in quarantine, what you basically have is that the mobility is not greatly reduced. Okay, so basically here we also observed that here when the schools closed on March 16, people were scared. So basically, not only it reduced because the schools closed, but because this mantra of stay at home was very strong and people were really taking it seriously and were able to stay home. Here we see the first lockdown and you see the reducing mobility. You see that Easter, which Friday is a holiday, you have that the behavior is similar to Saturday. May 1st and May 21st are two other holidays, and you can also observe reductions in mobility. It was quite interesting to see that the index, even though it was very simple, fast to compute, it was able to be so sensitive to what was going on. So for example, for Mother's Day, you could see the increase in mobility. Not as much as in Father's Day, for example. This is for just a larger period of time. And this shows another thing that we observed, and is the fatigue that you observe in long periods of quarantine, of lockdown. So basically, after some time, if you can observe, it's as if there was no lockdown. People started ignoring it. If the period was too long, in this case, it was like, I don't know, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, like almost 12 weeks of lockdown. People at some point just didn't care and they would go out anyway. So that's also some things that we analyzed with the government to see, to determine if it was worth it or not. This is the analysis at the level of the region. So here you can also see this fatigue. And well, so far we've developed 618 reports, and every week we generate 17 new reports. But I have to say that the last month we haven't been we haven't continued with the reports because things are stable and okay, so we became relatively famous. I was on TV very frequently. This is the Dean of the Faculty of Engineering presenting. The government would do a daily report for the citizens, and we were invited to present the results of the mobility. Well, here it's just more analysis of the same. The fatigue, where we analyzed the fact of the fatigue that made the government change the way they were actually imposing lockdown. They decided that they were going to say, okay, we're going to lockdown like for 4 weeks, like and try to avoid longer periods of lockdown. And also they try to, instead of sending to lockdown like a specific commune, they would send whole areas, not like realizing the impact it had the different communes over the others. Here, nothing. This is detail probably is interesting for someone from Chile, but here there's another interesting analysis, and this is we analyzed the mobility before the COVID pandemic and after the COVID pandemic in 15 minutes interval through the day. And here you see the morning peak hour, a lunch pickup during lunch, and then when people are traveling home, peak. This was the number of transactions done during the day before COVID. After COVID, the whole thing changed. Like there are no the morning peak was gone, and we had like a longer, more plain sort of peak. This also correlates very well with the data from the Ministry of Transportation in Chile. One of the researchers of our institute, Leo Ferris, with collaborators, worked on analyzing what happened with mobility and the epidemiological side of this. And basically, they tried to show that the measures actually significantly slowed the transmission, but not enough to stop the pandemic. Like Chile relaxed, like even in May, there were some talks about going back to normality, and that actually was too soon. And that's been shown with the analysis made in this paper. I'll share the PowerPoint presentation afterwards so that you can actually visit the papers and have a look at it. Also, we made some distinction and said, okay, what if we only consider the transaction, these transitions for residents, okay? So, for example, here we see that most of the movement in Las Condes is of floating population. And only this part of the index corresponds to local residents. This analysis was done also to understand what was happening. We analyzed in a specific town in the south of Chile to understand why they were not able to reduce mobility. And we realized that most of the movements in the town came from out of the city. And we were able to say from where, okay? So here is Las Condes, again, this commune is where the people from Las Condes go. So these are the communes where they go. And this is where the floating population in Las Condes comes from. So we were able to understand was the dynamic between the different communes, because we realized in some cases, for example, for Chillán, that the way to reduce mobility was to put a different town in lockdown. Okay, so this allowed us to make and also in that case, since they couldn't put the other area in lockdown, what they implemented was this sanitary fences where they didn't allow people to pass through it unless it was a medical emergency. We also did analysis at more granular level, this is our like like neighborhoods. Like, so this is Las Condes, and these are like small areas, and we understood how people moved within the different areas within a commune. So basically, that's what we did. Every day, we had the information, this mobility index for every day for every commune in the country. Okay. Well, the impact, the most important one, of course, is that the index was used by the government, even industry, and people from the society. Industry, for example, were using this gas company. They were using it to estimate the demand they were going to have from cars of gasoline, let's say. And the government to make decisions and to propose new strategies to control mobility. Here we have meetings with the military group, different municipalities. We presented to the Senate several times. I was part of the COVID data working group. We made the data available in the GitHub page of the Ministry of Science. We participated in the National TV COVID report, as I told you before, and I had the honor to be selected among the most influential women in Chile in 2020. So one of the things I want to especially talk about is that the government has this webpage where they actually have tons of data accessible through the GitHub, where our data is part of it. Here is the mobility index at a communal level. So this is our data. This is the minister. That's me. That's the dean of the Faculty of Engineering. And Demian, who has the biggest role in pushing this GitHub page, where there's tons of data to do research. Very interesting data set. Well, also the amount of press and outreach that we did was quite amazing. And I have to say, of course, this was a huge teamwork, but especially Leo Ferris was the lead of this project. He's the one that had the vision and said, you know what, we need to do something. Let's take the data. So he has the original idea and who developed it. So I have to give him credit. We had people from Telefónica helping us, from UDD, meetings weekly to analyze how else we could support the government. It was very challenging and interesting. Well, there are also some international collaborators, and that's what I wanted to tell you about the project. And to close and to open conversation, I wanted to present some projects that we're working on. Is, for example, with Telefónica, we're working on analyzing the new way of working, to analyze if people are working online, what are the types of companies that in which people choose to work online or on site, how they are mixing these two. With Fundación Paz Ciudadana, we are analyzing mobility and crime to find correlations and between crime and concentration of people and people moving in different at the level of a small grid of 500 meters. With Transbank, we are exploring still what projects we're going to work in, but we have, through them, we have access to the information of credit card transactions. Unfortunately, there's no way to connect the data of the credit card transactions with the data of Telefónica, because that would be crazy, and we could do amazing things, but at the same time, this is scary in terms of privacy. Of course, all this, we work with data that's very anonymized, and we, for each project, we anonymize the data in a different way so that we cannot cross the data. We have a very careful way of dealing with this sort of data. And also we most of the data, we access it directly at Telefónica, and we only take out aggregated data. Also with Santiago Smart City, we're working in mobility analysis in the metropolitan region using GPS data and video. We just got funding for this, so we're just starting. And also with the health ministry, we're working in analyzing how COVID variants have propagated in Chile. And if you have ideas of collaboration, we're more than interested in finding ways to collaborate and make use of this amazing data that we have access to. And that's it. I don't know if I used my time, if I was too fast.
It was perfect, Loreto. All very clear, and really your work is pretty amazing, also with a great impact. So yeah, thanks a lot for sharing this, because it was super, super interesting. We already have a few questions. So for questions, please feel free to send, write them on the chat, or just raise your hand and I will give you space to ask your question directly. So I have a few for you, but let me start with the one that are already in the chat. Vincent asks, if the call is made to a landline, how does destination tower variable looks like? He also notes that it might not be relevant anymore, but
no, it's a special type of tower. It's just a code that reflects you are connecting to a landline. We can actually know when it's a landline because we have the location of each of the towers, and for the towers that are landline, it says landline. So, but we actually get that data too.
Okay, thanks. Then, so another question by Iya is, how big were the data sets shared by Telefónica daily in terms of gigabytes? We might have had another connection problem.
Those numbers to see if he answers before we finish the talk. Sorry.
Sorry, Loreto. Sorry, I think we lost you
again.
Yeah, but just so
sorry.
If you can, no problem. If you can answer the question again, because I think we missed that.
So what I said is that I actually don't remember the number. So I'm going to ask Leo to see if he can answer for me.
Okay, thank you. Well, we might get back to this question later. So Mark Green, one of our lab member, also kind of wanted to highlight that you did a fantastic impact from your work. Well done. So I just want to report this. And then another question from Patrick. Also saying that this is an amazing work. What would you say is the greatest challenge in creating reports for government based on such fast-paced requirements? Did you and your team integrate any automated scripting report writing?
Okay, at the beginning, we were doing things ad hoc. Like basically we were working together with a team, a bit like, I don't know, PowerPoint presentations or something like really fast. We didn't even have time to write the script in Python. It was like just, we were running, trying to respond to the requests of the government. So basically we hired a small team that actually used Tableau to create like standard reports. So we had a set of standard reports created with Tableau, but we also developed a lot of reports that were by request. So I would get calls for, I don't know, the government, the person of the government in the south of Chile, and I would get a call midnight, like it's urgent, we need this. And it was really like, I felt like in a movie, like you were really running and trying to help with the data. And there was so much that we knew and so much answers that we could provide that actually we felt that we had to put this extra energy. So basically we had these two directions. We quickly developed this Tableau line so that we actually get the reports generated automatically with standard information that was distributed to the government and to the press. And in parallel, we had this direct line with the government so that the president would call the dean like, hey, we need this, and we would work like weekends. So yeah, It was a lot of work, but it was very gratifying.
Yeah, I mean, again, I mean, it had a great impact. So I think it's it is good when you see that your research kind of has influence somehow. So that's very good. I
have the answer to the amount of data.
Yeah,
we
go
got
ahead.
From March 2020 until now, we have 9.5 terabytes of data. It's 96 billion records.
Okay, that sounds a lot of data. Yeah, no, I had a question which is a little bit broader, because you also mentioned that the data provider was very keen on well, very responsive with your team, with yourself and your team over the pandemic. So I think that along with your case, I mean, we are seeing like a general improved, let's say, attitude from this data provider towards researchers in sharing mobility data during the pandemic. So my question is just what your thoughts are of the future. So do you think that this kind of collaborative endeavor from the data provider might remain even after the pandemic, and particularly given your experience with this data provider even before the pandemic? So
yeah, in our case, we were already sharing a lot of data beforehand. We were more restrictive in terms of the they would never give us the whole country and a whole month, and now we have 2 years of data for the whole country. So they already trusted us. We had a procedure. We knew how to anonymize the data. They trust how we will keep the data safe. So we had this history before that allowed them to actually give us so much access to the data. Now the other company in Chile, the biggest one, Entel, is also sharing data with one of the universities in Chile, with Universidad de Chile. But Entel processes the data much more and aggregates it before handing it in to the university. Because they started the collaboration during the pandemic. In our case, they were like, no, you do it. Like, we trust you. You go ahead and deal and use this data. So we will continue to collaborate. Our agreement finishes, like this second period finishes in January next year, but we are already working on the extension for another 3 years. So, and we work in both projects of interest to the company and projects of interest academically. So we're very lucky. And that's something that we would like to share. So we have the connection with Telefónica. If we present interesting projects, we can get access to new data. So if you have ideas, if you have things, let's look to collaborate. Let's find ways of developing new projects in this area.
Thanks, Loreto. Jacob.
A question kind of following exactly up on that point, because you mentioned your lab, you had like a really long relationship before any of this. You had this kind of long-standing relationship. And I think that goes a long way towards, getting the research and the data. But did you find that went kind of beneficial towards how the press and the public received the research? Because you said like a lot of times that press really liked it and that. Do you think that relationship, that that deeper relationship you have with the provider made a difference?
Absolutely, because they could see that they were also showing to the public that they were concerned about the pandemic, that they were helping, that they were doing something. So I don't know if you saw the numbers, but it was like in press, if you like give value to the amount of space and the amount of TV time and things like that, we had 7 million US. No, this is 7. This is weird. Yeah, 7. No, I don't know. I'm confused with the numbers now, but a lot of press. And that was very positive for both Telefónica and Cisco. It's what they were looking for in a way, of course. And also, they had a lot of internal negotiations with the government because there were a lot of issues of people not paying. So they also were showing, okay, we're doing something to help, not paying for the phones, and the government was requesting for the numbers not to be canceled. So there was this whole negotiation in which Telefónica was saying, okay, sure, we're going to help, but also notice we're already helping in this. There are different benefits to the agreement. And they like to have publications. They are also interested in patents and developing new products. We actually have a patent of estimation of the mode of transportation of the matrix of origin destination using telco data. And they are developing a product that they actually sell to the government of how to estimate the modes of transportation using telco data.
Yeah, which actually was one of my questions. So this on mode of transportation. So it's possible with those data also to detect transportation mode. But just relatedly to my previous question, but now moving to the policymaker side, you also mentioned in your talk that the objectives from their view have changed during the pandemic, and so I was just curious about how are you seeing those changes, and if again in a post-pandemic situation you think that this sort of collaboration that it seems clear might have a significant impact in decision making. So do you think that after this experience, policymakers might somehow value more the potential of research in informing decision making?
Yeah, I think that is a result of our work, but also the result of the work of the whole research community in Chile. The amount of data that was shared and the knowledge that was, I don't know, the ideas and the analysis that were provided for the government was amazing. It was like the dedication of the whole research community to helping to solve the problem and or to deal with it or to mitigate the effect it might have was overboard. Like everybody was on it. So that changed a bit the view the government had of this very theoretical and inaccessible and not useful type of research. So yeah, I think it's going to change. And now they have this idea of asking, of saying, hey, you know what, we have this worry, like what can we do with this? I think it's going to make a difference. And also what we said before, the predisposition or the interest of companies to actually see impact done through the data.
Thanks. Well, this seems quite promising, I would say. Just have a couple of questions that are a bit more focused on the data specifically. So you mentioned at a certain point that now you also have the kilobyte downloaded for each record, right? So is that a sort of proxy of the duration of staying as well? So
not necessarily. There's a very big influence of the type of plan that you have, the speed at which you download. There are too many variables. There's no research, like no data to analyze that. So we actually don't know. We did analyze. We did some tests. Well, the Telefónica did some tests in which people went to walk in the city to see what was the effect of the GPS location with respect to where you were walking, to see what was the difference between GPS and we're working on that too, because that's another topic that's relevant. Like how far are you really from the antenna that you connect to? So we're doing an experiment related to that.
Okay, thanks. And just well,
I shared my email in the chat, so if anybody's interested, please email me and we can find a time to talk.
absolutely. And I think we will circulate. And if you want to share the slides, I will.
Yes, I will.
Them,
I'll send them to you so that you can share them with the group.
Perfect. So just a quick one from me, the very last one. At a certain point, you showed a plot of the daily trend.
Yeah.
And that was like, well, the change was mostly like a flattening of the curve that generally has two peaks.
And the removal of the morning, I think it's related to the fact that there are no schools.
Schools, or I was also thinking homeworking might also affect. I don't know in Chile the extent to which homeworking has been implemented. So
it's been very extent. Like there's a lot of like schools opened like I don't know 6 months ago, and most of the students were allowed to continue studying from home. So they were doing like a hybrid sort of classes. So some students were local, like on site, and some others were online. I'm working from home. I go like once or twice a week to the university, and it's been very hard to move back. Like people don't want to. They want to mix the mix. They want to spend some days at home, some days at work. So that's why you see the flattening. Like people wanted also to avoid the crowds, and the idea of the morning peak is generally like the worst one. So probably that also moved the morning peak. Yeah.
Thanks. Well, I don't know if there's any. Let me see the chat. If there is any other question.
Here, Jacob is asking, please send along the GitHub repos or links to reports. I'll do.
Yeah,
together with the slides.
Any additional information is more than welcome, and we will share that. So if there are no further questions, I would thank Loreto again. I mean, this was really an impressive work, very extensive, and your presentation was brilliant. So thank you very much. We all really enjoyed that. I mean, now there were, people thanking you from the audience as well. So again, thanks very much. And I think we'll keep in touch. So I'll share everything. I mean, you email me the presentation and we can then keep talking.
Okay.